We're just going to work some more trig identity problems so that we work on one side of our equal sign. Just a few more examples, and we'll work some more homework on that today before we move on to more trig identities. So this first example says, prove that the tangent of x times the cosine of x equals the sine of x. This is one where we can use that first technique where all we're going to do is rewrite tangent in terms of sine and cosine. And we're working on the left-hand side. Here's my left-hand side, and it's equal to my right-hand side. I'm not changing my right-hand side at all. I'm just going to copy it down every step that I go, and I want the left-hand side to equal that right-hand side. So if I rewrite tangent as sine over cosine, then multiply it by the cosine that's there, those cosines cancel, and that just leaves the sine of x, which does indeed equal the right-hand side, which is the sine of x. So there's a pretty simple, straightforward example. Let's work another one here. We're to prove that the tangent squared of x equals the sine squared of x times the cosine of x to the negative 2. See that negative 2? We can definitely have the cosine of x raised to the power of negative 2, which behaves just like it would if it was x. We cross the line, we change the sign on our exponent. So we're going to work on the right-hand side. We're not going to do anything on the left-hand side. Our left-hand side will always be the tangent of x quantity squared, and we will do that every step of the way as we use good algebra and good calculus. So we're going to rewrite the right-hand side. It is the sine of x quantity squared times 1 over the cosine of x quantity squared. We can rewrite that as the sine of x squared over the cosine of x squared. We know that if we have a squared over b squared from our exponential rules, that's the same thing as a over b quantity squared. That's all we've done from this step to this step. If my numerator is squared, my denominator is squared, then I can rewrite that as a fraction quantity squared. And sine over cosine is tangent. So another really straightforward example. So now we want to prove that the tangent of x plus 1 over the tangent of x equals 1 over the sine of x times cosine of x. So we're going to work on the left-hand side. We're going to leave the right-hand side the way it is, and we want to rewrite the left-hand side until it matches the right-hand side. All right, so tangent is sine over cosine. 1 over tangent is 1 over sine over cosine, so we would take that bottom fraction and we would flip it and multiply straight across. That's how we get cosine over sine. Now we want a common denominator with these two fractions. If I'm going to have, instead of two fractions, only one, then my common denominator has to be the product of both of those denominators. Right? That's how we got to this step. So I'm going to look in this numerator, see what's missing from its denominator, and that's what I have to multiply it by. The whole well-chosen one thing. Just as if it was a number, sine and cosine have to behave the same way. So if I have a common denominator of cosine times sine, that means I'm going to have to multiply that numerator by what's missing from this denominator, which is sine. The same thing here. I'm going to have to look at this denominator and multiply the numerator by what's missing from the common denominator, which is cosine. So now I have sine squared of x plus cosine squared of x, which remember is the Pythagorean identity, and it equals 1. So now, indeed, I have manipulated the left-hand side so that it looks like the right-hand side, and I have proven this identity. One final example. Let's look at this last one. The sine squared of x over 1 minus cosine equals 1 plus cosine. So let's see what we can do here. I know that the sine squared of x can be rewritten as 1 minus cosine squared. And that is the difference of two squares. So that's 1 minus cosine times 1 plus cosine. And those cancel. And sure enough, my left-hand side equals my right-hand side. I know those weren't complicated, but at least it gives you more of an idea. You saw more techniques, and all you're attempting to do is work on one side to get it simplified, changed, to use your identities, to use algebra, to get it to simplify and look like the other side. So that's all. Come to class next time. We'll work some more identity problems.